Okay, now we're going to run some bivariate correlations, and I want to highlight a few key factors. The first database that we're going to use that I'd like you to open is in the K-12 database, and again, it's called Teachers 2. Teachers 2. Open that database, and then have out outputs 15. Output 15. At the top of output 15, you'll see the graphs that I drew representing a very positive correlation on A, graph V, a very negative correlation, and graph Z, a close to zero correlation, meaning there's no relationship between the two variables. When we look at correlations, we have to not only consider whether they're positive or negative, you should also explain whether they are of a small, medium, or large magnitude. And those magnitudes are called effect sizes. A small correlation is often considered in the 0.3 or smaller range, somewhere in that 0.3 something down. That's considered a small correlation. A medium correlation is in the 0.4 to 0.6 range, and any correlation 0.7 or above is a very strong one and considered a high correlation. So the practice test that we're going to run on output 15A is the number of years a teacher is taught in a school related to their level of commitment to the school. And years taught in the school is called Q34A in the database. Level of commitment to the school is called commitment. In other words, if I've been teaching longer in school, I'm more committed as a teacher to that school. So what we're going to do is, when we look at that question and we think of that flow chart from the very first module, we say, what research design are we in? Well, that keyword relationship. Is there a relationship between level of commitment and years of teaching in that school? That keyword relationship tells me I'm in correlational design. The next thing, again, I would ask is, how many variables? Well, I have 2. I have teacher commitment and years of service in the school. That 2, think of the word bi, so I'm running a bivariate correlation with that question. So I'm going to go up to Analyze, and now I'm in a correlational research design, so I scroll down to Correlate, and I see Bivariate, and I click OK, because I got 2 variables. So now I need to find those 2 variables. So I'm going to scroll down towards the bottom, first of all, and then work my way back up, and I see commitment. Commitment to the school, I'm going to move that over, and now I'm looking for Q34A. And you can see it's about 4/5 of the way down. Q34AM. Move that over, and you will see the default being on Pearson. So Pearson is one type of correlation represented by a small r. I'm looking for the bivariate correlation between commitment and years in the school. I could click OK. As a default, I'm running a 2-tilt test. If I wanted to, I could say, well, I'm expecting people who stay in a place longer to be more committed to that place. So therefore, I'm just going to run for a positive relationship. I'm just going to look in one tail. I could do that. The other thing I could do is, rather than run a Pearson, there are 2 other options. You'll see Kendall's and Spearman's. And you use those with data that are not continuous variables, but they're ordinal. So that might be like degree level. A degree level high school education, some college, master's degree. That's not continuous like a number from 1 to 100. It's just 4 different categories. And when you have categories, then you should not run a Pearson, you should run Kendall or Spearman. Honestly, if you just ran Pearson every time, you'll get the same results, but the most technically accurate test when you have ordinal categories as opposed to 2 continuous variables is to run a Kendall or Spearman instead of Pearson. So I've got Pearson set up because I've got 2 continuous variables, how committed teachers are to a school and how many years they've been teaching at that school, and I click OK and I get this little box. First of all, when you look at this table, it becomes obvious that commitment to the school and commitment to the school, the correlation is a 1 because it's the same 2 variables. So these 1s are really non-interpretable. The correlation I'm looking at is here. What's the relationship between commitment to the school and the years of service to that school? Interestingly enough, the little r, the bivariate correlation, is a negative 0.023. In other words, people who are at a school longer, in this particular case, those 1,309 teachers that answer both questions, there's really no significant relationship, but if it was significant, it would be negative. In other words, the longer you are at a school, the less committed you are to the school. Maybe you feel stuck, maybe you're burned out, I don't know. But it's not a significant correlation. The accurate answer here is there's no relationship between commitment to the school and years of service at that school. And the reason that is because the significance of 0.411 is greater than 0.05, meaning there's no relationship. The correlation is the top number, as you can see from the labels going across. The significance level, the p-value, is the second number, and the third number is the number of teachers that answered both questions. So that's a bivariate correlation, and specifically, that's a non-significant bivariate correlation.